All right, everyone, welcome to our Module 11 video. Just a few quick reminders. Don't forget you must be engaged 5 out of 9 of our online learning weeks to keep your current grade. So whatever's in PowerSchool, as long as you're engaged for 5 out of 9 weeks, then that grade will stay the same. If you are not engaged 5 out of 9 of those weeks, then your grade will be lowered 1 letter grade from where it was before spring break. So check Mr. Brooks's emails. He's been sending out each Monday that tells you how many weeks you've been engaged in this class. And let me know if you have any questions. And then you can still retake learning targets through this week only. So you got 3 more days through this Friday to retake those, which all that information was in Module 9 that we did a couple weeks ago. So if you'd like to retake, you have till Friday. Check Module 9 out for directions. And we have 1 week left, and it's actually summer. I just finished my master's degree yesterday, actually. I took my last final, so I'm excited to be done with that, and I know you guys are excited to be done here soon. Just real quickly, this was from our last module assignment that you guys turned in. Most of you turned that in, so great job. Thank you for doing that. There's a lot of great things. This was actually number 1. And there were a lot of people that canceled these out and said that the answer was 9. Okay. And then I also had some people that just canceled the 3. And then they gave me an answer of x plus 9 over x. Okay. This numerator is grouped together with a plus sign. So even though there's no parentheses there, it's assumed because they're both on the numerator, they're added to each other. Okay, and this 3 is multiplied to x, so I can kind of understand why some of you canceled the 3's because they are multiplied. However, that x is added to something else. Those are grouped together. So the only way to be able to cancel that 3 is if you factor out the 3 from both terms. So on the top, if you divide out a 3, that leaves x plus 3 behind. And by doing that, you're taking the 3 out of both of those terms, and you can then cancel that 3 with the denominator, okay? So the answer for that was x plus 3 over x. And then be aware, you cannot cancel those x's because the one on top is added to something else. You cannot undo adding with division, and that's what we're doing. When we cancel stuff, we're dividing it away, okay? So just be careful of that. Today we're going to add and subtract rationals, and this is actually going to be our last lesson over rational functions. So the first day was simplifying them. The second day was multiplying and dividing them. Today we're going to add and subtract them, okay? So we're going to take a trip back to elementary school for just a second, and if I start going too fast or you need to write something down, pause the video and then just press play whenever you're ready. Okay, so number 1, back in good old 4th grade, we added fractions with common denominators. Okay, so in order to add fractions, which is different than multiplying and dividing, you have to have a denominator that is the same. Okay, once those numbers are the same, which on number 1 they already are, you just add straight across the top. So 1 plus 9 would be 10, but the denominator stays the same. You do not add those together. And then obviously we would reduce. 10 divided by 5 is 2. Okay, so common denominator. On number 2, these do not have a common denominator. And 2 does not multiply into 3, and 3 does not multiply into 2. So what we need to do is multiply them to be the least common multiple that 2 and 3 go into, which would be 6. So if you multiply 2 times 3, but beware, you also have to do that same thing to the numerator in order to keep your fraction balanced. And then this 3 needs to be multiplied by a 2, and then same to the numerator. So our first fraction becomes 3 over 6, which we know is just an unreduced form of 1/2, but if you put that in a calculator, you'd still get 0.5 as a decimal, plus, and then our second fraction, 4 times 2 would be 8, 4 times 2 would be 8 over 6. And then once those denominators are common, we add across the top, so we would get 11 over 6, which does not reduce, so that's my final answer. Okay, on number 3, these denominators, 5 actually multiplies into 10. So this is a scenario where we would only need to multiply one of the fractions so that it is the same as the other, okay? On number 2, we had to multiply both fractions. But here, if I just multiply this 5 by 2, top and bottom, that denominator becomes a 10. So we get 8 over 10 minus 11 over 10. And then 8 minus 11 would just be negative 3 tenths. Once again, that does not reduce, so that is our final answer. So that was a review of kind of the basics of adding and subtracting fractions. We're now going to apply that to our rational functions or our rational expressions, okay? So rational expressions and equations have excluded values. An excluded value is any number that would make the denominator 0, as fractions cannot have a denominator of 0. That's an undefined fraction. Some expressions may have more than one excluded value. Okay, so if you're ever asked what values have to be excluded for x, well, if you look at the denominators, if you take that denominator, which in this case they're the same, if you set that equal to 0, because we know that technically x plus 6 cannot equal 0. And then if we solve for x, that means x cannot equal negative 6. So in this case, our excluded value, and there's only one of them because the denominators are the same, are negative 6. And it's pretty obvious to see if you plugged in negative 6 for x, that would give us a denominator of 0, which is an undefined fraction. You can't add or subtract undefined fractions. Okay, so that's just excluded values here. Okay, now let's do the actual adding. So number 4, we already have a common denominator. So our answer is going to be over x plus 6, we already know that. And then we just add straight across the top. Basically, we combine like terms. So x plus 2 plus 3 would just be x plus 5. Now, you always want to simplify your fractions. So if you go all the way back to lesson 1 and that example that I started with today, simplifying your fractions, if it can factor, you need to factor it to see if it will simplify. In this case, these are both binomials. There's no GCF, there's nothing to factor, so that is your final answer. Okay, on number 5, these denominators are clearly not the same, okay? But we can really only do things to fractions if we can compare factors, because everything we do is multiplying, so we need to see what's multiplied here. So the first thing you should always do is factor anything that can be factored. So on this, this would factor to x minus 1, x plus 6. Now you can see this denominator actually already has a factor that's in common. Both of these fractions have an x plus 6. But notice the fraction on the right does not have an x minus 1. It's missing a factor, just like we did on that elementary school example. So what you need to do is multiply this denominator times x minus 1. But if you multiply the bottom, you also have to multiply the top times x minus 1. Okay, so ultimately, this first fraction just stays as x plus 2 over, and then you can just keep the denominator factored, just in case we have to simplify, plus, but when you multiply 3 times x plus 1, or x minus 1, we're going to have to distribute here. So this denominator is going to become 3x minus 3 over, and now that denominator is common. So we have the x minus 1 and the x plus 6. Now remember, you only add across the top. That is why I'm keeping the bottom factored. That one doesn't really matter. I don't need to add anything together. But the top has to be in standard form. It cannot be factored because we have to add these terms together. So if I add across the top, I have x plus 3x. So that would give me 4x. And then I have constants here. I have 2 minus 3, which would give me minus 1, all over the common denominator. And nothing on the top factors. So our final answer is actually this right here. And the excluded values, you have to exclude any x values that cause any of the factors in the denominator to be 0. So if you look at this factor, that could not be a 1. That x value could not be 1 because 1 minus 1 is 0. And if you look over here, this could not be -6 because -6 plus 6 is 0. So in this case, our two excluded values are 1 and -6. Okay, once again, if I get ahead of you or if you need to take a second to pause this so you can write these examples down, go ahead and do that. I'm going to go ahead and do the excluded values for number 6. You can do it at the beginning or at the end. It really doesn't matter. You just have to make sure you include all values of all the denominators. So in this case, that could not be a -2, and this could not be a 5. So we need to exclude -2 and 5 from the possibilities for x. Even though we're not solving, there's no equal signs here, we still have to say what x cannot equal. Otherwise, that makes this problem not simplifiable. We cannot subtract these together. Okay, so on number 6, these denominators are completely different. So this is kind of like this example here. We had to multiply this denominator times 2 and this denominator times 3 so that they both became 6. So basically, we multiply them by each other. So this is a very similar example. This denominator needs to be multiplied times an x minus 5. And then you also have to multiply that on top. And I just like to put parentheses around everything because all these binomials are grouped. And then this denominator needs to be multiplied times x plus 2, which also needs to happen on the top. Okay. So now remember the bottom can stay factored, but the numerator does need to be FOILed out so that we can simplify the numerators when we subtract across the top. Okay, so the numerator of the first fraction, if we FOIL this out, would be x squared minus 10x plus 25 over the common denominator, which remember the denominator can stay factored, minus, and then x plus 2 times x plus 2 would be x squared plus 4x plus 4, all over that common denominator that now has both of the factors. And once that's done, we just subtract across the top. But don't remember, this was actually our very first essential standard this year. When we're subtracting something from another, a polynomial from another polynomial, you have to subtract all the parts of it. So in this case, we need to subtract all 3 parts of the quadratic on the second fraction. So you can kind of think of it as distributing the negative through. So on our numerator, we have x squared minus x squared. So those actually cancel out. Okay, and then we have negative 10x, but then remember this minus goes to the 4. So negative 10 minus 4 would be negative 14x when I subtract those. Okay, so when you're subtracting fractions, you really got to pay attention to distributing that negative. Okay, and then on the last term, we have a 25 minus 4. So that just becomes a 21 all over the common denominators. Now remember, we always have to simplify at the end, okay? And this numerator does have a GCF. 14 and 21 both divide by 7. And both of these are positive x's, so I also need to factor out the negative. So for example, if I factor out a negative 7, that would turn both of these into, or this would be positive, so 2x, but that changes this to a minus 3. All over x minus 5, x plus 2. Now in this case, nothing cancels, but had this factor ended up being either of these, we would have canceled them like we did on our last lesson. Just be careful of that, and then you can always leave your answer factored. Okay, I'm going to give you a second to do number 7 on your own. Okay, I'll give you a hint. You need to factor both denominators. So factor both denominators and then see if you can do the whole thing on your own. Okay, I'm going to pause the video and I want you to pause it. I want you to see if you can do it on your own. And then I will write out the answer when you play it to have it ready to go. All right, I'm going to go ahead and play this here. I got the first few steps done. So when you factor this denominator, you get x minus 1 times x minus 1. This one's x plus 1, x minus 1, because that's a difference of 2 squares, okay? So you can never take anything away. You can't just delete something. We can only multiply into something that makes them the same. So in this case, this factor had an x plus 1, and this left side didn't. So I had to multiply the left side by an x plus 1. The left side had 2 factors that are x minus 1, so we had to multiply the right side by an x minus 1. So the common denominator actually has 3 factors in it, and I went ahead and simplified x minus 1 times x minus 1 as x minus 1 squared. So if you want to pause the video and kind of check your work, and if you need to fix anything, you can. At this point, it's the easy part. We just subtract across the top. So x squared minus x squared, those cancel again. And then a lot of people look at, those cancel. A lot of people look at these x's and they're like, oh, x minus x, those cancel too. But you have to be careful there, it's being subtracted. X minus negative x, okay? You have to pay attention to the minus sign in the middle. So that's actually plus x would be 2x. All over the common denominator of x plus 1 times x minus 1 squared. And obviously there's nothing on top to factor or simplify, so that would be your answer. And our excluded values, this could not be -1, and this could not be +1. So we have to include both -1 and +1. Sorry, that's a plus sign. +1 from our denominator values. All right, last question today. It's a bonus. This will be definitely in pre-calc and college algebra. So this is one of those questions. It's really just good to know and be prepared for. So I'll try to go fast here. It's an equation. And the way that we solve equations, first we need to get common denominators. So this is x minus 1. This one's an x. But this, you can see if you factor out an x, it's just the combination of both of those, x minus 1 times x. So this is going to be our common denominator. So on the left side, this first fraction needs to be multiplied by another x on top and bottom. And this second fraction needs to be multiplied by an x minus 1 on top and bottom. I actually don't need to multiply the third fraction by anything because that already had the common denominator of x times x minus 1. Okay, so this first fraction just becomes x squared on top over x times x minus 1 minus, and then this becomes 3x minus 3 over common denominator equals 1 over x times x minus 1. Okay, now when we solve a fraction, really the only thing that matters is the numerators. The point of the denominator is just that they're all the same, okay? So at this point, what you can do is basically ignore the denominators. I'm going to put this in parentheses though before I erase that denominator because it was subtracted, so we need to keep that in mind. But we can get rid of the denominators and basically you're just solving the numerators, okay? So this becomes x squared and then minus 3x plus 3, because we needed to subtract that whole fraction, right, equals 1. So at this point, you can see we just have a quadratic here. X squared minus 3x. And then remember, to solve a quadratic, we got to get set equal to 0. So we subtract that 1 to the left, and that gives us 2 equals 0. And happy day, this fraction does factor. So the factors of 2 that add up to -3 would be -2 and -1. Negative 2 times negative 1 is positive 2, but negative 2 plus negative 1 adds up to negative 3. So therefore, my answers are 2 and 1. But now, even more importantly, you have to check the denominator, because now this is an equation, okay? Well, let's go back to the original and remind ourselves what x cannot equal. If you look at these factors, 1 would make that factor 0, so x cannot equal 1, okay? X could not be 0 either, because if this was a 0, well, 0 times anything is 0, and the whole denominator becomes 0. So we have to exclude 1 and 0 from our answers. So this answer actually doesn't work. If you plugged that number into the original equation, the denominators would be 0, okay? So that's where these excluded values are really important, is when it becomes an equation. So actually our only answer here is 2, okay? That is all for this video. Have a great weekend.